Hey everyone, in this video we are going to solve the all nodes distance k in binary tree question on Leetcode. So we are given a binary tree and a target node and a distance k, and we have to return all the nodes from that target node to in that particular tree at distance k. So in this particular example the target node is 5 and distance is k. So all nodes at distance at k are 3 is at distance 1 is at distance 2, and 6 is at distance 1, 2 is at distance 1, and 7 and 4 are at distance 2. So the output is 1, 4 and 7. So this is the question. Let's see how we can do it. So if we just had to move downwards, that would be a pretty easy thing to do. We just go from root to its children and we keep a count of how much or what level we are at to get the distance at to get all the nodes at distance k. But in this situation we need to move upward as well. But in binary tree we cannot do so. We cannot do like go back from 5 to node 3. So to solve this issue, what we can do, we can convert this binary tree to a graph. So we can create an adjacency list like 3 and all the nodes connected to 3. So 5 comma 1. Similarly for 5 nodes connected to node 5, which are 3, 6 and 2, and so on and so forth. So we can create an adjacency list of this particular graph using a normal DFS or BFS, and then after that, once we get the graph, we can start from this target node 5 and then run a BFS algorithm from here on. From 5 we can move to its connected node and increase the distance by 1. So if we move from 5 to 6, we'll increase the distance here by 1. From 5 to 3 will increase by 1. Similarly for 2 we can increase by 1, and so on and so forth. And once we move even further, so from 2 we can go to node 7, so here distance will be 2, and from 2 we can also go to node 4, so here also distance will be 2. So at each traversal, each node from u to v will increase the distance by 1. Similarly from 3 to 1, from 5 to 3 we had a distance of 1, and from 3 to 1 we have a distance of 1. So in total it will be 2. And we'll keep checking. If the distance become 2, we'll push it to our result array. So the result array will contain all the nodes with the distance 2 from target node 5. In this case, these are 7, 4 and 1. The time complexity of this question will be O of n, and space complexity will also be O of n, because we'll be storing all of these when we'll be running a BFS, and so we'll be storing all of these nodes in a graph. So let's see how we can do it in code. So we'll create a function. Let's call it build graph. This function will take a root node, will return us the graph in the adjacency list format. So let's first write this build graph function. Build graph. It will be a function and it will take the root as argument. And first declare a graph variable. We'll be using map data structure to create the graph, and we'll be also be using a queue to get all the connected nodes. Then let's create a helper function called add to graph. It will take two things. It will be let's create an arrow function. It will take two things, two nodes, and it will basically just create it will basically just add these two nodes in the adjacency list. So if graph dot has e, so if a key of node e is already available there, if they are already connected nodes, then we just need to push the node v in the list. So we'll write graph dot get node e dot push node v. Else, if that is not the case, we'll simply create a new key value pair. So graph dot set key will be node e and value will be an array with node v in it. So let's run a loop to traverse through our tree. While q dot length is greater than 0, let's pop first element from our queue using the shift method. So q dot shift. Now we'll check if it has the right, left child and right child. So if node dot left is present, we'll push it to the queue. Node dot left, and also we'll update the adjacency list to connect node and node dot left. So we'll call this helper function add to graph, and we'll pass node and node dot left. Similarly, we need to create vice versa on the from the other side as well. So again calling add to graph, and this time passing node dot left and node, since it's an undirected graph. We'll do the same thing for node dot right. So if row dot right is present, push it to the queue, queue dot push node dot right, then call the add to graph helper method and pass it node and node dot right. Again call add to graph method, and this time pass node dot right first and then node. Okay. Then at the end of this function, we'll just return the adjacency list or our graph variable. Now once we get this graph, we can just run a normal BFS. So for that, let's create a queue here as well. We'll start from the target node. We'll create a variable result as well to store all the nodes at distance k. We'll create a visited set as well to check what node we have already visited, so we don't repeat them. So new set. Let's create a variable to calculate the distance. So let's call it current distance. Initially it will be 0. Now let's run a while loop. So while q dot length is greater than 0 and current distance is less than equal to k. So let's calculate the size of our q dot length. Then let's run a for loop. For let I equal to 0, I is less than size, and I plus plus. Let's get our node first using q dot shift method. Let's add it to the visited array as well. So visited dot add this current node. Now we'll check if current distance is equal to k. If this condition is true, we'll just push this node to our result array, node dot val. We'll get first just check if the node is present in a graph as well in the adjacency list. So if graph dot has node, then we'll get all of its neighbors, all of its connected nodes. So const neighbor of graph dot get node, so all the neighbor of this node. So we'll check if not visited dot has neighbor, then we'll push it to our queue dot push neighbor. After each iteration, we'll increase the current distance by 1. So current distance plus equal 1. And at the end of this, after this while loop, we'll just return the result array. Okay, so let's run this. Okay, node dot left, line number 29. Okay, so actually I made a mistake inside our build graph function. Instead of node dot right, I wrote root dot right. So if I fix this and run again, yeah, it's working. Let's submit it. Cool. So that was it for this video. Thank you for watching.